Hi, this is Swapnil Bharti and we are here at KubeCon and Cloud Native Con in Shanghai, China. And today we have with us Sheng Liang from Rancher Labs.
That's right.
It's nice to see you.
Very nice to see you too.
Yeah, it's been a pleasure because I've been chasing you for a while, so it's good to be sitting down with you and talking again.
Likewise.
Yeah, and you delivered a talk with Goldwind, which I think one of the largest manufacturers of wind turbines in China.
That's right. They're the largest in China, third largest in the world.
Excellent. That also means that they have totally, because when I think about wind turbine, I just think about, machines, I don't think about IT infrastructure, but I am aware that they may have a lot of sensors there, how they, detect everything. So can you talk about what kind of, IT infrastructure they have, because you work very closely with them?
Yeah, it turned out one of the biggest problems they actually needed to solve was to gather all the sensor data they have with all the wind turbines, and then use that to forecast the status of the system, and also especially the situation with the weather, with the wind speed, because that has a very big impact on the power output, which impacts the grid stability. So it's because of the large amount of power these power stations actually generate. It's a very difficult problem, and it's a distributed and edge computing problem by nature, because even though the power companies, the headquarters are largely centralized, but they actually function in many different states and provinces, and then inside each province they actually have many different plants, and a plant would have, so they basically have this three-level IT structure. They have a central location where the headquarters of one of the power utility is, and then that utility would serve a number of provinces or states in China, and then each of these states essentially would have a second-level data center that does a lot of data processing. And then finally, at each power plant, which could be built in fairly remote locations, there will be some edge computing nodes. And each edge computing nodes would manage dozens of, a few to dozens, maybe up to 100 wind turbines.
In what capacity are they using, can you tell us about the open source technologies?
Yeah, they built they developed this whole technology pretty much in-house, built using open source technologies from the ground up. They use a lot of storage technologies. They use object storage technologies. They use sort of analytical big data storage technologies like Hadoop-like technologies. And then they use AI technologies that they use to try to learn about the weather patterns and predict the speed of the wind and direction of the wind. So it's a fairly sophisticated system. So the challenge they have really was how to distribute this software stack to a number of locations, both their central location and the regional, the state and province level data centers, and especially all the way out to the edge locations. And there's actually a lot of commonality. They have a common sort of AI big data platform they actually distribute everywhere. And it's microservice based. It's built out of pretty much the same set of open source components, the big data and storage and AI that I talked about. And then that's why they use Kubernetes. So they have a unique challenge of actually running multiple Kubernetes clusters. We investigated potentially using one big Kubernetes cluster, because these locations are connected, but the bandwidth is not that high, and that bandwidth has to be primarily used to actually take in the sensor data itself. So there's really not that much extra bandwidth available to run hundreds or thousands of kubelets across across half of China or half of a major big country, and they sell worldwide, right? And then collect the data. So I think in one particular deployment they talked about in the talk, there are actually over 600 Kubernetes clusters. Most of them exist in these edge locations, and they have to have a way to distribute and deploy these Kubernetes clusters, and then they have to have a way to manage these Kubernetes clusters.
So how is Potential helping them out?
Yeah, so with Rancher basically provided two pieces of technology that was all part of Rancher product that solved their problem. One is we have a Kubernetes distro, a Kubernetes installer. I mean, it's in principle it's not unlike many other Kubernetes installers, but I think we built it to be particularly easy to use and particularly efficient. So it's called Rancher Kubernetes Engine, and they find it very useful. So they use Rancher Kubernetes Engine to basically build these Kubernetes clusters, both in the central or regional data center as well as on the edge. Then the other aspect of Rancher that they find it useful was multi-cluster management. So Rancher provides a unified management plane across really any Kubernetes cluster in theory. I mean, you can, other Rancher customers actually use Rancher to manage GKE clusters or Huawei CCE clusters, as well as clusters they built themselves. But in this particular case, they just use Rancher to manage the Kubernetes clusters they built with RKE, and then they can pretty much write a script once, and through Rancher it can kind of get all of their software updated. Then we'd be like monitoring the health of these clusters and also the applications running on top of these clusters. We'd be upgrading the clusters as well as the applications running on top of these clusters. So this is this is basically the challenge that they have that Rancher solved.
So as you help Goldwind, what was the biggest challenge that you saw they were facing?
Yeah, they talked about it in yesterday as well. It's really quite fascinating. So there were technical challenges and sort of not so technical challenges. A lot of the technical challenge was around the resource consumption of Kubernetes itself. So it turned out we're actually not able to completely use Kubernetes across all their edge nodes. Some of their edge nodes are fairly sizable, so Kubernetes is okay, but some of the smaller ones, they only have 8 GB of memory. And once you deploy even a single node Kubernetes there, it takes up half of the resource. So it's a little too heavyweight, and we're motivated by this and by a bunch of other customers with similar requirements. At Rancher, we've actually embarked on an effort to dramatically slim down the weight of Kubernetes. Kubernetes is really nicely modularized code, so you can really remove a lot of stuff you don't need without really impacting the rest. So I think this problem could be solved. We really want to push the envelope of how small Kubernetes can go. I know a lot of developers run Kubernetes like Minikube on a laptop. It doesn't seem to take that much memory. But the reality is, once you put on real workload, right, it actually increases the memory footprint quite a bit, even in a Minikube situation. So we're going through a round of optimization, and I'm fairly optimistic. Working with the community, we can make progress in this direction. The challenge is because we don't really want to, like in this case, we don't really want to just run kubelet. If we could get away with just running kubelet on the edge, it would have taken a lot less memory footprint. But the problem is then the whole system is just not as isolated, not as reliable. And because, like I said earlier, the networking is kind of really their bottleneck, and it's not entirely reliable because it's built on it goes through telcos and stuff. So they really wanted an independent Kubernetes cluster at the edge. So this is sort of I would say one of the major technical challenges that they're still working through, and we're working with them. Then there are more sort of organizational challenges. It comes from two directions. One direction is their internal operations team are actually struggling with Kubernetes quite a bit, even today, especially some of the more experienced IT operations personnel just really struggle to learn some of these concepts, because a lot of these guys they are not really DevOps engineers by traditional definition. They're more like just IT admins, and they're more comfortable with virtual machines or physical machines or networking, and this is just all new. It's a little overwhelming. And another thing is I think this whole technology is not quite completely built up. So some of the complexities of the infrastructure in Kubernetes is actually exposed to some of the AI data scientists, and they don't quite like some of the worries now they have to pay toward the infrastructure. So we basically need to do more work to really abstract some of the Kubernetes complexity away, so data scientists and AI engineers would feel more comfortable with it.
So yeah, I mean, you rightly said, these are some of the smartest people, and they will be solving this problem, and they'll keep making Kubernetes better and better. So thank you, once again for talking to me today. And as usual, I look forward to meeting you again. Thank you so much.
Thank you very much. Bye-bye.